Hey students, this is a lecture on section 9.6, which is about inequalities. So inequalities are kind of like equations, except instead of the equals symbol, you're going to either see less than, greater than, or you're going to see less than or equal, or greater than or equal. So inequalities have those symbols. So this is less than, that's greater than. And then this one is less than or equal, that one's greater than or equal. So the line underneath it gives you the or equal part. Okay, so these ones here are less than and greater than. Less than or greater than. Whereas these two over here are less than or equal and greater than or equal. So this one is less than or equal. And then this one on the right is greater than or equal. Okay, so those are the names for them, for those symbols. And we're going to be learning how to use those symbols in conjunction with graphs and also what's called interval notation. Okay? And we're going to start with some basic ones. Okay, so example. Graph the inequality on the number line. Graph the inequality on the number line. Okay, then write the solutions in interval notation. Then write the solutions in interval notation. Okay, and for problem number one, we have the inequality, which is x is less than or equal to -3. X is less than or equal to -3. So remember, if it's pointing to the left, it's less than, and if it's pointing to the right, it's greater than. And this one is less than or equal because it has the line underneath it. So, like we said up here, less than or greater than does not have a line underneath it, whereas less than or equal and greater than or equal, they do have lines underneath them. And that extra line means that the graph also can be equal to the number. Okay, so this one is saying x is less than or equal to -3. So they want us to graph first. So using a number line, you sketch a number line and then you sketch the number that they gave you. So remember, 0 is in the middle of the number line, and then negative numbers are to the left of 0. So here -3 would be over here somewhere, right? -1, -2, -3. Now this is read x is less than or equal to -3, and less than actually goes to the left, because remember, lesser numbers are on the left, so smaller numbers are on the left side, and larger numbers are on the right side. Okay, so if x is less than or equal to negative 3, that's going to be everything to the left of negative 3 because all the smaller numbers are to the left of negative 3. So less than goes to the left. So to graph our inequality, I'm going to put a bracket at negative 3, and then we have everything to the left of negative 3. And why am I using a bracket? Well, it turns out that whenever you have less than or equal or greater than or equal, you're supposed to use this bracket, which looks like kind of like the edges of a rectangle, the corners of a rectangle. Okay, so going back up here, for less than or greater than, you want to use parentheses, whereas for less than or equal or greater than or equal, you want to actually use brackets. Okay? So for less than or greater than, you're going to use parentheses. Okay, so they look like normal parentheses. Whereas then, if you're using less than or equal or greater than or equal, you want to use brackets. Okay? Okay. Cool. So what we've got here is because it was less than or equal to negative 3, it was one of these symbols, we used brackets. So we used a bracket at negative 3. And then less than means all the numbers to the left are all the smaller numbers than negative 3. So I had my inequality start with a bracket at negative 3, and then it was everything to the left, where all the smaller numbers are. So this right here is called the graph. That was the graph that we made on the number line. And that was the first thing they asked us to do. And then from the graph, you can get what's called interval notation. Okay, so they asked us to write our solutions in interval notation. So for interval notation, you look at this interval right here, and you want to write it out. So this arrow to the left is actually negative infinity. So the arrow to the left actually goes to negative infinity. Okay, so our interval here is going to actually be a parentheses at negative infinity, comma, negative 3 with a bracket. Okay, so we have parentheses, negative infinity, comma, negative 3 bracket. So when you're writing your interval notation, you write the left side, which here was negative infinity, that was the arrow to the left, and then you write the right side, which was a bracket at negative 3, and then you join those two with a comma. Okay, so again, this thing that I wrote right here is called our interval notation. Okay? And so that's what we're going to box. So that's the interval notation right here. And then up here we have our graph. So those are the two things that you're going to have to enter into MyMathLab. And it takes a while to explain it, but once you get used to these, they actually are pretty easy once you get used to all the notation and everything. Okay, so let's take a look at problem number 2. Problem number 2 is x is greater than 17 halves. So x is greater than 17 over 2. So for 17 halves, you might want to just divide that on a calculator so you can write it as a decimal. Or you can do it in your head. Some people can do that in their head. But 17 divided by 2 is 8.5. Okay, so this is really saying x is greater than 8.5. Okay, which is good to know because we're going to have to graph it. So we need to know where to put it on our graph. Okay, so let's start with the graph here. So we want to graph 8.5. So here's 0. Here's, we can count in whatever we want, but on my math lab, it looks like on these they count in 3s. So I'll count in 3. So 0, 3, 6, 9, and 12, and so forth. And what we want to graph is we want to actually have a parentheses. Now, why are we going to use a parentheses? Well, it says x is greater than 17 halves. So remember, with greater than or less than, you use parentheses. So we're going to have a parentheses at 8.5, and then greater than goes to the right. So we're going to put a parentheses, 8 is like right there. And then we have a parentheses at 8.5 between 8 and 9. And greater than goes to the right, because larger numbers are on the right side. So that's actually going to be our graph right there. So you see we've got a parentheses opening to the right because it's greater than. And then I did my best to put in 8.5. It's between 8 and 9. That's 17 halves. And then greater than goes to the right because larger numbers are on the right side. So there's our graph. Okay? And then we need to write our interval notation. So for interval notation, we start on the left side of our graph, which remember is 17 halves. So the left side of our graph is actually 17 halves. So for interval notation, we're going to have parentheses, 17 over 2, comma, and then the right side of our graph is actually infinity. It's positive infinity. So the left side of the arrow to the left is negative infinity, but the arrow to the right is positive infinity. Okay, and for negative infinity and positive infinity, you're always going to be using parentheses when you're writing out the interval notation. So like on the last problem, we had negative infinity on the left side. That was the arrow to the left. We put parentheses, negative infinity. And then for this one, on the right side, we have positive infinity, and our graph is going out there. So for our interval notation, we're going to write parentheses, 17 over 2, which is the left side, and then comma, infinity, parentheses on the right side. So parentheses, 17 halves, comma, infinity, parentheses. So always use parentheses for infinity and negative infinity. Okay, and that's actually the whole problem. So this one right here is the graph, and then this one right here is the interval notation. Okay, so with that, you should be good for quite a few of your homework problems. But there are some other ones that are a little bit trickier. So let me get into a trickier problem. Okay, so example number 3. This one is written in a strange way. So example number 3 is 8 is less than or equal to m. Now m is just a variable, so you treat m as if it were x. So you just leave it like that. But the weird part about this problem is the variable is on the right side instead of on the left side. And that's not good. You don't want to have it written that way because it can confuse you a lot. So what you do is you want to write the variable on the left. Write the variable on the left side. Because otherwise the graph is not going to work properly. Okay, so how do you write the variable on the left side when it's already on the right side? Well, you just flip the whole thing around. So when you write it on the left side, you flip the direction of the inequality. Okay, so if I move this m to the left side and the 8 to the right side, I have to flip the direction. So instead of being less than or equal, now it's going to be greater than or equal. So those two actually mean exactly the same thing, And the reason that is because if you move the m and the 8, you switch them around, and you switch the direction of the inequality, then m is still greater than or equal to 8. You can actually read this one as m is greater than or equal to 8. It's because if m is greater than or equal to 8, that's the same as saying 8 is less than or equal to m. So they actually mean exactly the same thing. But you want to write the variable on the left side. That way it's a lot easier to graph. Because if you have the variable on the right side, you can mess it up. It's easy to mess it up. Okay? Alright, but now that we have it in this format, we should be able to use it. So we know because we're using a greater than or equal, we're going to be using brackets. Okay? And so we're going to have a bracket at 8, and greater than goes to the right. So we're going to have a bracket at 8, and greater than goes to the right. So this is going to be our graph here. Bracket 8, and then greater than goes to the right. And on the right side there, that's going to be positive infinity with the parentheses. And then 0 is over here somewhere. Okay, so there's our graph. Alright, and then for our interval notation, the left side is a bracket at 8. And then the right side of our graph, we can see goes to infinity with parentheses. So it's bracket 8, comma, infinity parentheses. Alright? So that one was a little bit tricky. Just beware, you always want to have your variable on the left side when you have a single inequality like that. Otherwise it can throw you off. Because if you left it this way, you might think, well, less than or equal goes to the left. So you might think that the inequality was actually supposed to go to the left. But no, that's not true, because that only works if the variable is on the left side. So it has to be on the left side of the inequality. Okay, and the next thing I wanted to show you is called a double inequality. A double inequality. So that's a little bit different. So for this one, we have -1 is less than or equal to y, which is less than 2. Now, if you look at it, I think we can all see why it's a double inequality. Because it actually has two inequality symbols. The variable's in the middle, and we have two different numbers here. But these are actually pretty easy to do if you know how they work. The thing is, for the less than or equal, that means we're going to use a bracket. We're going to use a bracket at -1. Whereas for the less than at 2, we're going to be using a parentheses. Okay? And then to graph this, this is called a double inequality. This is called a double inequality because it has two numbers and the variable is sandwiched in the middle. But the thing is, because the variable is sandwiched in the middle here, it's pretty easy to graph because the -1 is going to be the left side of your inequality and the 2 is going to be the right side of your inequality. Okay, so bracket -1 is the left side, and parentheses 2 is going to be the right side. So literally the way it's written from left to right, because the variable is between those numbers, a double inequality is actually not going to ever go to infinity. It's just going to have the variable sandwiched between these two numbers. Okay, so when we do the graph, what we can do is we can put a bracket at -1. So we got bracket at -1. Here's 0, 1, 2. And we're also going to have a parentheses at 2. That's going to be the right side. And then our variable y is in between these two numbers, which means our inequality is actually going to be this part in the middle. So I shade that in. So that right there is actually our graph. Okay, so double inequalities really just mean the middle part in between the two numbers. Middle part between the two numbers. Okay? All right. Okay, so we're going to start doing some more advanced inequality problems now that we've seen all the basics. But I almost forgot to write my interval notation here. So let me write my interval notation. So as you can see with this graph here, that's our graph. And then the interval notation, well, the left side is a bracket at -1. And the right side is a parentheses at 2. And then for your interval notation, you want to join them with a comma. Okay? All right. So anyway, as I was saying, I want to do some more challenging problems. Okay, so number 5. Number 5 is a little bit more complicated looking. For this one, we have 4x minus 4 is greater than 3x minus 5. 4x minus 4 is greater than 3x minus 5. So now with this, this inequality is not solved. So we actually are going to have to solve this inequality first. And we solve an inequality a lot the same way we solve an equation. So solve by performing operations to both sides. Actually, I'm basically going to say solve just like an equation. Solve just like an equation. So you perform operations to both sides, except you flip the direction. So you switch the sign, you flip the direction. When multiplying or dividing both sides by a negative number. By a negative number. Okay. So you solve it just like an equation by performing operations to both sides, except you flip the direction of the inequality whenever you multiply or divide both sides by a negative number. And on a lot of problems, you're not even going to end up multiplying or dividing by a negative number, so you don't even have to worry about flipping the direction. Okay, but you do want to isolate the variable on the left side. You don't want to isolate it on the right side. Okay, and just like an equation, if you imagine if this were covered up and this were an equation, well, we have a 4x on the left side and a 3x on the right side. We want to get rid of the 3x because we want to isolate x on the left side. So what I'm going to do here is I'm going to minus 3x from both sides. Okay, minus 3x from both sides. So when we do that, on the left side we're going to have 4x minus 3x is x. So we have x minus 4 is greater than negative 5. Okay? So we're solving just like an equation. So we're performing operations to both sides, and we're trying to isolate the variable on one side. Okay? And but we still haven't isolated x. So here we have x minus 4 is greater than negative 5. So to finish isolating x, we have to get rid of the negative 4. Okay, so to get rid of the negative 4, we're going to have to add 4 to both sides. So I add 4 to both sides of this inequality. So on the left side, now we're just going to have x. And then on the right side, negative 5 plus 4 is negative 1. Okay, so we get x is greater than negative 1. And now the inequality is solved. This is considered solved, so I'll underline it. And once you have it in this format, then it's just the same as the earlier problems. So now they want us to graph it. So to graph this, because it's a greater than, we're going to use parentheses. We're going to use parentheses. And greater than goes to the right. So we put a parentheses at -1, and then we go to the right. We shade in everything to the right. And then 0 is like right here. Okay? And on the right side of our graph, the arrow going to the right is positive infinity. Okay, and we're always going to use a parentheses for that. So for our graph, here we have parentheses, -1, and then the graph goes to the arrow to the right, which is going to positive infinity. And then for our interval notation, we can see the left side of our graph is -1, parentheses -1, and then the right side is positive infinity, parentheses. And we join those with a comma. Okay, so that's a little bit of a trickier problem because it had the additional parts where we're solving at the beginning. Okay. So let's see another one like that, but with some other tricks. Okay, so number 6. Problem number 6. 2x minus 2 is less than or equal to 5x minus 4x. 2x minus 2 is less than or equal to 5x minus 4x. So first of all, we need to solve this, and we need to get the variable on one side. But on the right side, notice we actually have like terms. So we're going to want to combine like terms on the right side. So 5x minus 4x is 1x, which is just the same as x. So now we're going to have 2x minus 2 is less than or equal to x. But we don't want to isolate x on the right side. We want to isolate it on the left side. So we need to get rid of this x on the right side. So we'll get rid of it by subtracting x from both sides. Okay, so on the left side, 2x minus x is x. So we have x minus 2 is less than or equal to 0. Okay, and then to finish isolating x, we need to get rid of the -2. So the way we do that is we add 2 to both sides. Add 2 to both sides. Okay, so that gives us x is less than or equal to positive 2. And now it's considered solved because we have the variable isolated on the left side. Okay? And then now we're ready to graph this. So because it's a less than or equal, we're going to be using a bracket, and less than goes to the left. So we're going to have a bracket at 2. We have a bracket at 2, and then less than goes to the left because smaller numbers are to the left. And so our graph is going to the arrow to the left, and remember that that arrow to the left is negative infinity with the parentheses. Okay, so there's our graph. Okay, and then our interval notation, we can see the left side of our graph is parentheses negative infinity. Okay, and then the right side of our graph is 2 with a bracket. So it's parentheses negative infinity, comma 2 bracket. And most of the other problems you should be good for those now. The only thing I wanted to show you was, I mentioned it, if you have an inequality and you end up having to multiply or divide both sides by a negative number, you do have to flip the direction of the inequality. So that was the last thing that I needed to show you. So let's take a look at this next problem. Okay, so this is going to be problem number 7. Negative 5x is less than or equal to 25. negative 5x is less than or equal to 25. Now this problem is pretty simple to solve. It's pretty easy to isolate x on the left side. But the way we do it is we have to divide both sides by negative 5. And the problem is, if you're multiplying or dividing both sides of an inequality by a negative number, you have to flip the direction. So it has to switch around. So if I divide both sides by negative 5, I have to flip the direction. Because that's a negative number, and I'm multiplying or dividing by a negative number, I have to flip it. So it was pointing to the left, now it's going to be pointing to the right. So it's now going to be greater than or equal. So on the left side, the negative 5's cancel, and we just have x. And then on the right side, 25 divided by negative 5 is negative 5. Okay, so we actually get x is greater than or equal to negative 5. Okay, so we solved it. That one was actually pretty easy to solve, but it had that extra trick, so I had to show you that. Okay, and then the next thing we're going to do is graph it. And because it's greater than or equal, we're going to be using brackets. And greater than goes to the right. So we're going to have a bracket at negative 5. And then our graph goes to the right. Okay, so bracket negative 5, graph goes to the right. And remember, the right side of your graph is the same as positive infinity. So there's positive infinity with a parentheses. And then 0 would be somewhere over here. Okay, so there's our graph. And then the last part is our interval notation. So for our interval notation, we can see the left side of our graph is a bracket at negative 5. And then the right side of our graph is infinity with a parentheses. So we have bracket negative 5, comma, infinity parentheses as our interval notation. Okay? And that should get you good for your homework. The only other thing that shows up in your homework is one of the problems has 0, but I think we all know that 0 divided by any other number is still 0. So that shouldn't be too bad.